Although their names are interchangeably used, cement and concrete are entirely different products. In fact, cement is one of the primary raw materials used in the production of concrete, along with water and aggregate. The process of concrete making starts with making cement, the crucial binding material that holds the water and aggregates together in concrete. There are many different kinds of cement, but the most commonly used is ordinary Portland cement. It was named by its inventor as such because its color resembled the stone chlorine on the Isle of Portland in Dorset, England. The primary raw materials used in cement production are limestone and clay. They are typically obtained from quarries by blasting or using heavy machinery to extract them from the Earth's crust. The extracted materials are transported to the crushing plant, where they are crushed into smaller pieces. The crushed limestone and clay are then mixed in appropriate proportions to form our raw meal. The raw meal is transferred to a mill, which consists of a large rotating cylinder inside the mill. The raw materials are ground into a fine powder. This grinding process enhances the efficacy of the subsequent chemical reactions and ensures the uniformity of the raw meal composition. The powdered raw meal is then heated in a preheated tower where hot gases from the kiln are used to raise the temperature. As the raw meal moves through the preheater, it undergoes partial calcination, which means that some of the carbonates in the limestone decompose to form calcium oxide lime. The preheated and precalcinated raw meal enters a kiln, which is a long centrifugal furnace. The temperature in the kiln reaches around 450 degrees Celsius or 260 to 42 degrees Fahrenheit. In the kiln, the raw materials undergo a series of complex chemical reactions in situ, resulting in the formation of small marble-sized nodules called clinker. The clinker consists of calcium silicates, aluminates, and ferrite. The clinker is discharged from the kiln and passes through a clinker cooler where air is blown through it. To reduce its temperature, cooling the clinker is important to maintain its quality and prevent the formation of undesirable crystal formations. The cooled clinker is then ground with gypsum and other additives such as fly ash, slag, or pozzolan cement. Mills to produce fine powder gypsum is added to control the setting time of the cement. Once prepared, the cement is ready for transport to the concrete factory because cement is such a crucial part of concrete cement plant. Laboratories check each step in the manufacture by frequent chemical and physical tests. The labs also analyze and test the finished product to ensure that it complies with all industry specifications. Now that the cement is ready, it's time to source the aggregate. Aggregate is the most important component of concrete, comprising up to 75% of concrete by volume. When it comes to composition, aggregate is composed of both gravel and the sand is added, so the spaces in between the gravel are completely filled, thereby giving the concrete stronger bonding and consistency. A well-graded aggregate, which is a balanced mixture of coarse and fine particles, reduces the requirement of cement, thereby making the whole process much more cost-effective. Now is a great time to talk about the hidden stars of concrete manufacture. The admixtures. These chemicals offer a range of advantages and may be added to concrete to improve its properties. Plasticizers give the concrete greater workability, which refers to its ability to be easily molded and placed without segregation or excessive bleeding of water, allowing it reach congested areas. Accelerators, soarators, or tarders are another type of admixture that fasten or slow down the setting time for concrete. Due to the fact that concrete cracks under tension, many chemical additives have been developed to increase the tensile strength of concrete. Concrete may also be best strengthened by using fibers made of stainless steel, glass, and carbon wit. Their raw materials, all their concrete production can finally begin. The first step is to measure the proportions of cement, aggregate, admixtures, and water based on the desired strength and characteristics of the concrete. In fact, concrete mix design is an entirely different discipline dedicated to finding out the right proportions of raw materials in order to reach a target tensile strength. Moreover, building codes have been developed that specify the ratio of cement, aggregate, and water based on the different types of construction. The next step is to mix the ingredients thoroughly to create a uniform mixture. Traditionally, this was done manually using shovels on a flat surfaces such as a concrete slab. However, nowadays concrete mixers are commonly used, which automate and speed up the process. The mixing process ensures that the cement particles are evenly distributed throughout the aggregates. Once the dry ingredients are mixed, the water is added gradually while continuing to mix. When water and cement are mixed together, a paste called cement paste is formed. The hydration process generates sheet and cont in use over an extended period, gradually increasing the strength and durability of the concrete. The mixing process continues until the concrete has uniform consistency. During this step, it's important to check the workability of the concrete. The consistency of the concrete can be adjusted by adding more water or dry ingredients as necessary. Once the concrete is mixed and has the desired consistency, it is transported and placed in its final location. This can be done by pouring it directly into formwork molds or by using specialized equipment such as pumps or conveyors during the placing process. It's important to avoid segregation, which is the segregate station, of course, aggregates from the rest of the mixture. After the concrete is placed, it needs to be properly compacted to eliminate any voids or air pockets. This is typically achieved using vibrators. By mechanical means, such as tamping or rolling, compaction ensures that the concrete is dense and has good strength and durability. Once the concrete is placed and compacted, it needs to be cured. Curing is the process of maintaining adequate moisture and temperature conditions to allow the cement to hydrate and gain strength gradually. This typically involves keeping the concrete damp, covering it with curing membranes, blankets, or plastic sheets. Curing can last for several days or weeks, depending on the type of concrete and desired strength. After the concrete is cured sufficiently, various finishing techniques can be applied to achieve the desired surface texture and appearance. This can include technique such as smoothing, leveling, troweling, or applying decorative finishes. Owing to its versatility, cement is the most widely used construction material. In just the United States, over $4 billion worth of hydraulic cement, a variety that hardens underwater, is produced annually for use in $20 billion worth of concrete construction globally. The concrete industry is estimated to be over $600 billion, which, trust me, is a lot of zeros.